Good afternoon, ladies and gentlemen. My name is Vladimir Toporovsky. In collaboration with Institute of Geosphere Dynamics, Moscow Polytechnic University, Institute of High Technologies and Piezo-Technics, and aka Optics, we present our work with the title Stacked-actuator deformable mirror with rigid design made of piezoceramic combs. The goal of research is development and investigation of stacked-actuator deformable mirror with high reliability for compensation of high-order aberrations of the high-power laser beam propagated through turbulent atmosphere. The problem of compensation of distorted wavefront is relevant in different scientific and industrial tasks such as astronomy, free space communications, remote sensing. As well known, refractive index inhomogeneities of the turbulent area cause wavefront distortions of optical waves propagating through the atmosphere, leading to such effects as beam braiding, beam wander, and intensity fluctuations. These distortions are responsible for severe signal fading and therefore compromise optical link reliability. The aberrations arising due to the propagation of light through a turbulent or scattering medium are compensated by means of adaptive optics. Wavefront is analyzed by a wavefront sensor, which makes it possible to determine the shape of the incident aberrations, and after corrected by flexible mirror. The key element of any adaptive optical system is wavefront corrector that defines its performance. Considering the different types of wavefront correctors, some of them should be highlighted. For example, biomorph deformable mirrors, mechanical one, MEMS mirrors, or liquid crystal spatial light modulator. But all these correctors have some shortcomings that make them is not applicable for correction of higher order wavefront aberrations of the laser beam propagated through turbulent atmosphere. For example, inability to use correctors with high power laser radiation, low spatial resolution of elements, or low operating speed. The most suitable kind of mirrors for correction of higher order aberrations changing with high speed are stacked actuator deformable mirrors. Conventional stacked mirror consists of a thick basement substrate with the glued piezostack columns composed of a set of thin monolayer piezoceramic discs sintered with each other. A thin mirror substrate is glued to the other end of the piezoactuators. The outer surface of this substrate is deposited with a multilayer dielectric or metal reflective coating. However, traditional stacked mirrors have some shortcomings: high cost, labor-intensive process of manufacturing, and large dimensions of the mirror. One of the most important criteria of using one kind or another of deformable mirrors is the cost of the device. Therefore, we propose to manufacture stacked-actuator deformable mirrors from multilayer piezoceramic combs. It will allow to get scalable wavefront correctors and decrease the risk of failure of control elements during assembling process. During manufacturing of such elements, the blank with the length of 24 mm and width of 4 mm was cut in the individual piezoactuators with the size 4 by 4 mm, with the gap between them equal to 1 mm. One comb contains 5 piezoactuators in the row with electrical connection to every part of the comb. As a producing material with PZT-based ceramic, due to its high sensitivity to applied voltage, a high curie point, and high electromechanical coupling coefficient. By combining on the rigid base made of piezoceramic material, such combs we can assemble stacked mirror with desirable configuration of actuators. In our case, we choose the net of 10 by 10 actuators. After assembling, to investigate key parameters of the mirror, we use the diagnostic setup that represents traditional adaptive optical system. As optical source, we use laser diode with wavelengths 650 nanometers and Schacht-Hartmann wavefront sensor to analyze mirror characteristics. The main parameters of the mirror are shown on this slide. As you see, such deformable mirrors should be well suited for setups where space is limited and adaptive optical systems with high operation speed are required, due to the high first resonant frequency and small mirror aperture. In the future, we are going to produce such deformable mirrors from monolithic piezoceramic block. The upper part will contain many piezoceramic plate layers with conducting electrodes in between, and the lower part is a thick solid piezoceramic material serving as a base to support the matrix of multilayer piezoceramic stacks. Thank you for your attention.